In this video, we're going to talk about causal link diagrams, and they complement the systems maps that you'll find in another video. The idea of causal link diagrams is that we focus on cause and effect, and so it's a very good way of summarizing high-level understanding of cause and effect. The example I want to talk about is physicians and patients in the province of Ontario. And so if you started thinking about that system, you might say that we've got patients that are seeking physicians, as one group, and we would have physicians seeking patients. And if you think about those two phrases that I've written there, they're nouns, right? And so what you're going to find is that when we make causal link diagrams, we'll have nouns, which are sort of the entity, if you want, and then we'll have actions. And so the cause and effect really then says, what's the effect of a specific action on something? So we could organize it this way and say, okay, here we've got patients seeking physicians, and here I've got physicians seeking patients. And you could come to me and say, okay, so what if the number of patients seeking physicians increases? Okay, so in other words, if I had a positive change, the number of patients seeking physicians increased, what's the effect on physicians seeking patients? And so what you might do is step back for a minute and say, okay, well, if more people are seeking physicians, it means that they're going to be taking up those spots from the physicians seeking patients. And so if more people are looking for doctors, the number of doctors looking for patients is going to decrease. And so we would put a minus sign there. And what this says is that if the number of people looking for doctors goes up, what's going to happen is the number of doctors looking for patients, is going to go down. So it has an opposite direction, if you wish. Okay. And then we might set that aside for a minute, and we might say, okay, what if the number of physicians seeking patients goes up? Okay, so when we do this thought process, what we do is we set aside the other links, and we just focus on this point here. If the number of doctors seeking patients goes up, then what they're going to do is draw down on the pool of patients seeking doctors. And so what would happen is that if the number of doctors looking for patients goes up, the number of patients looking for doctors is going to go down. And so again, we've got a change in the opposite direction, and so we would put a negative sign there. And so this is an example of a very simple causal link loop, as a matter of fact. I'm just going to get rid of these arrows here for a minute. Okay. And so one of the questions we can answer is, okay, so when we put this all together, what happens? Well, let's suppose that we've got more patients suddenly seeking more doctors. So this goes up. Okay. Okay. And then so what happens is that that causes a decrease in the number of doctors looking for patients because all those open spots are being taken up. Well, we know that if more doctors are looking for patients, the number of patients goes down. So conversely, if there are fewer doctors looking for patients, then the number of patients looking for doctors is going to go up. And so what you would find in this particular case is that this is actually a reinforcing loop. People that have done system dynamics would say it's an unstable loop. But really what it means is that if more people are looking for doctors, it draws on the doctor pool gets smaller, and more people are looking for doctors. And so it just goes around and around. And so it never stabilizes out, it never settles out. And so this is an example of what the systems thinking people would call a reinforcing loop. So R for reinforcing. And the reason that's actually a reinforcing loop is it turns out that the signs in the loop are all the same sign. And so it just keeps on building and building and building. Now, what would actually happen in the physical world? Well, in the physical world, what would happen is that we'd probably find that we would have patients who might just give up, okay? And so we might now all of a sudden have, or consider that we could have another cause, which is patients who give up. Like so, okay? So that might be another cause. And so we could say if the number of patients seeking physicians goes up, a certain percentage of those are eventually going to give up. And if we wanted to, we could put a plus sign there. And what the regulatory body, and actually really the government might do, is come along and say, well, okay, we've got a problem here. Okay, so let's take back that reinforcing loop for a second. And so what the province might do is they might say, we're going to consider medical school admissions. Okay. And so if one way you could actually build this diagram out might be to say, if we have more physicians seeking patients, the province might say, okay, that means there's too many physicians. Okay, so we might have this loop like so. And so if the number of physicians seeking patients goes up, we're going to drop the med school admissions because we've got too many doctors. And so this goes up, that goes down, that's a negative sign. And we also know that if the number of people going through med school goes up, it will translate into more physicians seeking patients. So if med school admissions and graduation go up, the number of physicians seeking patients will go up. Okay? And so now you can see we've started to build out a more complex kind of causal link diagram. And let's track through it again, okay? And see if maybe this is going to help, okay? So if the number of patients seeking, in fact, let me just use the orange arrow. If the number of patients seeking physicians goes up, okay, that's going to cause the number of doctors seeking patients to go down. If the number of doctors seeking patients goes down, then we would increase medical school admissions, because remember, this acts in the opposite direction. If we increase med school admissions, that's going to cause an increase in physicians seeking patients, but physicians seeking patients, okay? And if this increases, then this is going to cause a decrease in patients seeking physicians. And so I'll use the green dashed line again just to trace through that once more. We started out by saying, suppose that we have an increase in the number of patients seeking physicians. We said that causes a decrease, we'll call that 1, we'll call this 2. That causes a decrease in the number of physicians seeking patients, which causes an increase in the number of medical school admissions, which now increases the number of doctors looking for patients. And now reduces the number of patients looking for doctors. And so what we've done is, in a sense, added a controller, a regulatory loop. And so this would be an example of using a causal link diagram and saying, well, what if we did the following? What if we actually adjusted the number of medical students depending on some sort of moving average of the number of patients seeking physicians, or the number of physicians seeking patients? And you can see that this would actually now have the effect of essentially stabilizing or balancing that loop. So if we looked at it from that perspective, sort of from here, we would see that we've actually got what people would call a balancing loop. It actually settles out. Okay? And we can always pay attention on the side to the number of patients giving up. If we balance this out, then the number of patients giving up is going to go down because the number of patients seeking physicians is going to go down. So to recap, the way we actually set up a causal link diagram is we think about the entities first in this diagram. And by that I mean patients seeking physicians, physicians seeking patients, and so forth. Those are always nouns. And then the causality is associated with action. So it's associated with verbs. And so we go through a thought process and we say, what if patients seeking doctors goes up? What does that do to doctors seeking patients? And we just work our way through there. The critical thing to remember is that when you are trying to decide whether there's a plus sign or a minus sign with any one action, you just focus on the two entities. So you say, okay, on the left-hand side, if it goes up, what happens to the thing on the right-hand side? Okay? You don't pay attention to any of the other arrows coming into it. Otherwise, you'll get yourself really, really messed up. And so you go pair by pair, and then what you can do is look at the overall causal link diagram, and then assess how this all works together as a more complex system.